Hello everybody, and this is Vipul Purohit, and once again I welcome you to my YouTube channel. My dear friends, we are here to present about the chemical bonding, and that is of part 4. You have already gone through part 3 before, and I'm very sure that you must have understood everything about it. Alright, so now we go into the continuation part. If you remember, my dear friends, in part 3, we were discussing about the impact of lattice energy on the strength of ionic bonding. याद आ रहा है? Yes. Okay, हम लोग ने बताया था वहाँ पे कि lattice energy and the strength of the ionic bonding is directly proportional. Higher the lattice energy, higher is going to be the strength of the ionic bond. यानी इसका मतलब क्लियर हो जाता है दोस्तों कि अगर मुझे ionic bond के strength के बारे में पता करना है तो I need to know the value of lattice energy. And that is where the importance of determination of the lattice energy value comes into picture. And that is what we are going to discuss in today's video. About how to determine the value of lattice energy. Alright, so there are two equations to find out exactly how the lattice energy can be calculated. So we get a numerical value, and on the basis of this, the strength of the ionic bond can be calculated. So here we go with the first expression, and that is called as Bond-Lance equation. Now my dear friends, before I write down the expression or the equation, I want to make one thing very clear, and that is, I am here presenting the simplified form. Okay, it is actually in a complex form, but here as far as your syllabus is concerned, because I always tell you that I need to restrict myself as far as the syllabus is concerned. You are at the undergraduate level, so I need to also restrict myself to that particular level itself. Alright, so as a result of which I am here putting forward a simplified form of this particular equation. Alright, and that equation says the lattice energy, which is going to be denoted as UL, is equal to NA E square Z plus Z minus upon R into 1 minus of 1 upon N. Okay, this is the simplified form of the Bond-Lance equation to determine what? Oh yes, it's the lattice energy. Okay, now I'll explain to you the terms which are involved in this. Okay, the first one is N. Every one of you knows this. It is Avogadro's number. उसका वैल्यू भी आपको मालूम है, that is 6.023 into 10 raised to 23. उसके बाद हम बात करेंगे about A. A is a constant, इसे हम लोग बोलते हैं Madelung constant, and it is related to the geometry of the crystal. What type of the geometry that ionic crystal is having, उसके हिसाब से उसका A का value होगा. E, I guess everybody knows about this, and that is electronic charge, or we say the charge on the electron. Z plus and Z minus, charge on the cation and the anion respectively. Okay, Z plus and Z minus, the charge on the cation and the anion respectively. R, internuclear distance. And obviously it is between what? The two oppositely charged ions. Ion, it's actually called as a repulsive parameter. Its value varies from around say 2 to 8 depending upon the nature of the ions present. So these are the terms which are involved in this particular expression. So once again I just take a recap. The point number 1 is, and that is, we are here to identify the numerical value of lattice energy, because it is on the basis of that we are going to comment on the strength of the ionic bond. So one of that particular expression on the basis of which we can get the numerical value of lattice energy is called as Bond-Lance equation. Okay, so that is saying lattice energy is equal to N into A into E square Z plus Z minus upon R into 1 minus 1 upon N, and the factors are this. N stands for Avogadro's number, A is the Madelung constant, Z plus Z minus are the charge on the cations and the anions respectively, A is the charge on the electron, and N is basically a repulsive parameter. We also can say it is related to a beta factor. But then as I told you that we are here to put a simplified form in front of you. That is what my duty is. So as a result of which I'm just keeping it as simple as possible. Otherwise the complex form of this equation is different. Okay, but let us keep that aside for a moment, and we just simply say it's a repulsive parameter and the value varies somewhere between 2 to 8. Okay, so this is, my dear friends, the first part with respect to what? Lattice energy calculation on the basis of Born-Lance equation. We also have another factor, my dear friends. There is another way also of calculating the lattice energy, and that is based on the equation and called as Kappa-Stensky equation. What is it called as? Kappa-Stensky equation. Once again, it is related to the lattice energy, UL. So UL is equal to CV Z plus Z minus upon R plus R minus. Right? So, when you talk about C, it's a constant. Its value is around 1.079 into 10 raised to 5. V stands for the number of ions in the formula unit. नहीं समझ में आया? मैं आपको एग्जांपल से बता देता हूँ कि सपोज आई टॉक अबाउट NaCl. जब भी आयनिक कंपाउंड की बात होती है सबसे पहले दिमाग में क्या आता है? NaCl. नहीं आता है तो लाना चाहिए, याद रखिएगा. It is NaCl. तो इसमें कितने हैं? टोटल नंबर ऑफ आयंस है. Okay, that means it is very clear that is the number of cation as well as the number of anions. So there is one cation Na plus and one anion, that is Cl minus, and therefore the total number of ions are, yes, you guessed it right, it's 2. So for NaCl it is 2. Okay, the CaCl2 है दोस्तों. So there is going to be one calcium and 2 chlorine. So 1 plus 2, you heard it right once again, it's 3. Alright, that way we are going to consider. So ये हो गया V. Next one is Z plus and Z minus. My dear friends, you know it very well. Come on. Oh yes, you relate it from here. It's the charge of the cation and the anion respectively. The charge on cation and anion respectively. Alright. Next what is happening? Yes, it's R plus and R minus. See, we are doing the summation of the radius of the cation and the radius of the anion. So the two radii are being added, and that is actually giving us what? The internuclear distance. Alright, so we can also call it as a radii of the ions, or we also call it as the internuclear distance, and it is being expressed in terms of ppm. Okay, ये उसका unit है, वो याद रखिएगा. So either we say the radii, या फिर हम बोलेंगे उसको internuclear distance of the oppositely charged ions. Okay, तो ये हो गया दोस्तों about the second equation. और वो कौन सा है दोस्तों? Yes, lattice energy का उसका नाम क्या है? Kappa-Stensky equation. तो इस तरीके से दोस्तों देख सकते हो यहाँ पर there are two equations in front of you, one and both of them once again inverted commas please. Yes, क्या है? Simplified form. Right? So पहला है Born-Lance equation और दूसरा क्या है? Kappa-Stensky equation. So ये दोनों equations आपके सामने हैं. Okay, so both of them are besides each other, so it's very easy for you to comprehend, okay, the formula of that and what are the requirements so as to calculate the lattice energy. एक और बात बताना चाहूंगा आपको which is going to be applicable on the basis of both the equations, and that is lattice energy is based on two important factors. Okay, मैंने जो previous video था chemical bonding का part 3 उसमें मैंने ये बात बताई थी आपको the factors affecting lattice energy. Yes दोस्तों, yes, दो important factors है दोस्तों. कौन सा है? जी हाँ, एक तो है size और दूसरा है charge. तो अगर आप ये दोनों देखोगे अच्छी तरीके से तो हम कंक्लूजन क्या ड्रॉ करेंगे? The conclusion on the basis of both these equations is the number one is it increases. Obviously we are talking about with respect to what? Lattice energy. It increases with what? Increase in the charge of the ions. Okay, increase with the increase in the charge of the ions. देख सकते हो चाहे आप Born-Lance equation देखो या फिर Kappa-Stensky equation देखो. Okay, the charge is that is Z plus and Z minus are on the numerator. और numerator है तो obviously आप जानते हो कि it has to be what? Directly proportional. Okay, अब दूसरा है it is second point is lattice energy is going to be larger for smaller ions. समझ में आ रहा है दोस्तों? Yes, larger. Lattice energy के बारे में बात कर रहे हैं दोस्तों. So I guess that is no confusion. So larger for smaller ions. यानी ionic size has to be what? Small. तो lattice energy has to be what? Large. और दोस्तों देखिए आप दोनों इक्वेशन में कि R which stands for the size, क्योंकि कहीं ना कहीं internuclear distance की भी बात करें, so it depends upon the size of the cation as well as the anion. If the size of the cation and the anion is going to be large, so obviously the distance is large. Okay, so same thing is over here also. R आप देख सकते हो डिनोमिनेटर में है दोनों इक्वेशन में, और इस तरीके से ये साबित हो जाता है कि डिनोमिनेटर में है मतलब वो इनवर्सली प्रोपोर्शनल है. सो लैटिस एनर्जी हायर और लार्जर, so obviously the radii is going to be smaller, and that is what is written over here. So it's larger for smaller ions. Okay, so I hope you have understood this, how to determine lattice energy on the basis of these two equations, bond length equation as well as Kappa-Stensky equation. Okay, then here it is for you. Now my dear friends, once we understand the theoretical calculation of lattice energy using two equations, bond length equation as well as Kappa-Stensky equation, we go into the next part, and that is called as Born-Haber cycle. We call it as what? Born-Haber cycle. Now what is this? Born and Haber, these are the two different German scientists who experimentally have designed the determination of lattice energy. Okay, the previous two were the theoretical formulas or equations, but this one is an experimental technique of determining the lattice energy of ionic compounds. Now my dear friends, when we talk about ionic compound, the very first thing which comes in my mind is what? Yes, NaCl. Okay, Na, sodium, alkali metal, valency 1. Okay, Cl, halogen, valency 1. So when these two combine, the combination will be taking place in what? 1:1 ratio. Okay, so let us now apply this particular Born-Haber cycle by taking an example of the formation of an ionic compound. Okay, that is going to be an alkali metal halide. Okay, so alkali metal, give it as M, capital M, and X, consider it as a halogen. So we are here now to demonstrate the Born-Haber cycle with respect to the formation of an ionic compound MX. So let us start with it. We are going for two methods. The first one is called as a direct method. So as the name suggests, direct method का मतलब क्या है? Directly combine हो जाएगा दोनों. कौन combine हो जाएगा? Alkali metal as well as halogen. और वो क्या देगा? Ionic compound देगा. और दूसरा है फिर alternative method. क्योंकि जब भी एक मेथड हम लोग लिखते हैं दोस्तों, याद रखिएगा एक बात ओके गौर से, कि रिएक्शन को लिखना बोर्ड पे या पेपर पे और उसी रिएक्शन को वाकई में जाके लेबोरेटरी में करना अलग होता है दोस्तों. जब भी हम रिएक्शन लिखते हैं तो जनरली वन स्टेप में लिखते हैं. उसका मतलब ये नहीं होता कि लेबोरेटरी में भी जब हम एक्सपेरिमेंट करते तो वो एक ही स्टेप में हो जाता है. नहीं, उसको अलग अलग स्टेप्स भी लगते हैं, और ये एक्सपेरिमेंटल टेक्निक है दोस्तों. तो आज मैं वही आपको बताने वाला हूँ कि डायरेक्ट मेथड में जस्ट वन स्टेप रिएक्शन, जैसे हम लोग हमेशा लिखते हैं रिएक्शन ऑन पेपर, लेकिन वो रिएक्शन वाकई में लेबोरेटरी में कितने स्टेप्स में होगा वो मैं आपको बताऊंगा. और फिर वो दोनों मेथड को किस तरीके से इंटीग्रेट करेंगे वो मैं आपको बताऊंगा. है बहुत सिंपल, एक डायग्रामेटिक फॉर्म में मैं आपको ये बता दूंगा ताकि आपको ये समझने में आसानी हो जाए. ओके, ये मेरी जिम्मेदारी है कि आपको कैसे दिमाग में फिट कर दूं. आई बात समझ में? सो हियर वी गो, एंड दैट इज द Born-Haber cycle with respect to the formation of a ionic compound. So we take alkali metal, okay, M. आप जानते हो ये सॉलिड फॉर्म में होता है. सो वी टॉक इट एज सॉलिड. हैलोजेंस, जब भी दोस्तों हैलोजन की बात होती है तो याद रखिएगा दे आर इन अ डायटोमिक फॉर्म एंड दे आर जनरली इन द गैसियस स्टेट. Okay, fluorine is a gas, chlorine is a gas, of course bromine is a liquid, okay, and iodine is a solid. लेकिन iodine के बारे में बताना चाहूँगा दोस्तों कि उसका sublimation बहुत जल्दी होता है. And you know what sublimation is? Yes, it's solid getting converted into what? Gas. Alright, so generally we consider halogens as a diatomic gas. So I'm going to consider M plus X2, okay, which is in the gaseous state, and it results in the formation of MX. Okay. Now, when I talk about the enthalpy of the reaction, enthalpy का मतलब क्या होता है? Energy. Reaction is a process, और कोई भी प्रोसेस हो एनर्जी उसके साथ जुड़ा हुआ है, ये याद रखिएगा। बिना एनर्जी का कोई भी प्रोसेस नहीं होता। एंड व्हाट आई मीन व्हेन आई से एनर्जी जुड़ा हुआ है, मतलब आइदर द एनर्जी इज एब्सॉर्ब्ड और द एनर्जी इज रिलीज्ड। इफ इट इज एब्सॉर्ब्ड सो इट इज इन, आवत है, अंदर आवत है, एंडोथर्मिक। ओके, एंड इफ इट इज रिलीज्ड मतलब आउट, बाहर जावत है, मतलब इट इज एक्सोथर्मिक। So with respect to the energy, the reactions are either endothermic or it's going to be what? Exothermic. ठीक है? So यहाँ पर what we talk about is M plus X2 giving you MX. It's a process of bond formation. ओके, और जब प्रोसेस ऑफ बॉन्ड फॉर्मेशन होता है दोस्तों, तो आपको पता है बॉन्ड मतलब फोर्स ऑफ अट्रैक्शन। और आप ये भी जानते हो अच्छी तरीके से कि प्यार से क्या हो जाता है, स्टेबिलिटी आती है, जिंदगी में ठहरावपन आता है कि नहीं? यस। और वही ठहरावपन को स्टेबिलिटी बोला जाता है, और उसी स्टेबिलिटी की वजह से एनर्जी में कमी आती है। आई बात समझ में? सो यहाँ पर एनर्जी में कमी आएगी, कमी मतलब क्या? नेगेटिव। ऑलराइट, तो इसका मतलब कि यहाँ पर जो मैं लिखूंगा डेल्टा एच एफ, सो आई जस्ट राइट इट डाउन एज माइनस ऑफ एक्स। ओके, या फिर what I'll do is I change the alphabet because you know there is an x over here also, so you might get confused. एक मैं लिख देता हूँ a because I haven't defined what is m, I haven't defined what is x, so exactly I cannot determine the value of how much amount of energy is released. Okay, इसलिए मैंने जस्ट एक अल्फाबेट रख दिया दैट इज a, और उसका यूनिट्स क्या होगा? किलो जूल्स पर मोल। सो दिस इज माय डियर फ्रेंड्स डायरेक्ट मेथड, डीएम। ओके, आप व्हाट्सएप पे लिखते हो ना डायरेक्ट मैसेज मी, डीएम। ओके, तो यहाँ पे थोड़ा उसका फुल फॉर्म थोड़ा अलग हो जाता है, दैट इज डायरेक्ट मेथड। ओके, द m plus x2 giving you what? mx. Enthalpy of formation, why formation? Because its bond is forming, releases energy and the units are kilojoules per mole. अब जैसे मैंने बताया आपको रिएक्शन लिखना है बोर्ड पे, वो एक बात है, और उसी रिएक्शन को वाकई में जाके लेबोरेटरी में करना है तो वो अलग अलग बात है। तो अभी उसके बारे में हम चर्चा करेंगे अंडर एम। ए मतलब सुबह नहीं बात करेंगे, ऐसा नहीं है, इट इज ऑल्टरनेट मेथड। ये कौन सा था? डीएम, दैट इज डायरेक्ट मेथड। वी नाउ गोइंग टू व्हाट? ऑल्टरनेट मेथड। तो अभी ऑल्टरनेट मेथड कैसा है, स्टेप बाय स्टेप आई विल एक्सप्लेन यू। ओके, एंड आई एम वेरी श्योर यू विल अंडरस्टैंड दिस। लेकिन बिफोर वी गोइंग टू दिस, ये पहले रिएक्शन को बैलेंस करना है। बिना रिएक्शन बैलेंस के कहाँ जा रहे हो? रुकिए, रुक जाइए, पहले बैलेंस करो रिएक्शन को। देखो यहाँ पे क्या है, इट इज इन टर्म्स ऑफ व्हाट? पर मोल। यानी यू हैव टू बैलेंस द रिएक्शन इन सच अ वे दैट this remains what? 1 mole. आई बात समझ में? This has to remain as what? 1 mole. Next thing is, because this is going to be stable, so it has to be generally in a solid state. Generally solids are stable. Of course, as compared to liquid and gas, please. Okay, मेरे शब्दों के अर्थ को अनर्थ मत कर दीजिएगा. Okay, generally ये मैं बोल रहा हूँ. Okay, तो generally solids are more stable as compared to liquid and gas. इसलिए मैं solid लिखा हूँ. यहाँ पे reaction को ऐसे balance करोगे. This remains as 1 mole. So what I need to do? Oh yes, you are very clever, you got it, it's half. Okay, so m plus half x2 gives you what? mx. Reaction balance हो गया. अब आगे बढ़ते हैं. So under the alternate method, the first step is metal is in a solid state. Okay, आपको मालूम है अच्छी तरह से ionic compounds are formed by transfer of electrons. Metal is going to lose electrons and the non-metal is going to gain electrons. You know all these things very well. ठीक है? Now, when you want to make sure that the electrons are lost, so मैंने अपने previous video में बताया हुआ है कि हर एक प्रोसेस में एनर्जी जुड़ा हुआ है. तो जब हम इलेक्ट्रॉन की बात करते हैं तो प्लीज रिमेंबर द डायरेक्शन ऑफ द इलेक्ट्रॉन and the energy direction are opposites. Okay, if electron is coming in, the energy goes out. Alright, and if the electron is going out, the energy goes in. तो यहाँ पर it's a metal, so electron has to go out, so energy should come in. अब solid में से इलेक्ट्रॉन निकालना है दोस्तों, बहुत एनर्जी चाहिए. ओके, तो जनरली जहाँ पर भी ज़्यादा एनर्जी चाहिए ना तो हम वो एक्सेप्ट नहीं करते. हम थोड़े से आलसी किस्म के हैं. ओके, जहाँ कम एनर्जी लगेगा हम जल्दी करेंगे, जहाँ ज़्यादा एनर्जी लगेगा बोलते जाने दो. तो यहाँ पर भी वही है. ओके, वी आर गोइंग टू मेक श्योर दैट द एनर्जी रिक्वायर्ड हैज टू बी एज लेस एज पॉसिबल. तो व्हाट वी डू इज, फर्स्ट ऑफ ऑल दैट सॉलिड वी कन्वर्ट इनटू गैस. Okay, because from the gas to remove the electron is much more easier. Alright, so that is step number 1. Solid getting converted into what? Gas. Mg. यही बात समझ में? ब्रैकेट कर दीजिए, नहीं तो वो अर्थ का अनर्थ हो जाएगा. गैसियस मेटल की जगह पर मैग्नीशियम बन जाएगा. ओके, तो जरा ध्यान रखिएगा इस बात. ओके, नाउ यहाँ पर क्या हो रहा है? सॉलिड इज गेटिंग कन्वर्टेड इनटू गैस. इट्स कॉल्ड एज सब्लिमेशन. क्या बोला जाता है उसको? सब्लिमेशन बोला जाता है. तो हम यहाँ पर ऐसा लिखेंगे, एंथैल्पी ऑफ सब्लिमेशन. एनर्जी देना पड़ेगा दोस्तों, because in a solid state the particles are much more closely attached with each other. The interaction amongst the particles is going to be more. So when I want to convert into a liquid and a gaseous state, I want to separate those particles away from each other. So obviously I need to give some energy so that the particle separation can take place. Okay, and that's why the energy has to be supplied. Energy goes in, so that is endothermic, और प्लस हो जाएगा because it is absorbed. रिलीज होगा तो कम हो जाएगा, तो माइनस. एब्जॉर्ब होगा तो बढ़ेगा, बढ़ेगा मतलब प्लस. तो इस तरीके से हम यहाँ पर लिख देंगे, एक अल्फाबेट दे देते हैं, +A किलो जूल्स पर मोल. ओके, तो ये हो गया स्टेप नंबर 1. सबको समझ में आया? द सॉलिड अल्कली मेटल, okay, is supposed to lose electron, but if I try to remove the electron from the solid, I require large amount of energy, which is not favorable. So what I do is, before removing the electron, I will convert this solid alkali metal into a gaseous metal, and then I will remove the electron. Alright, so that it becomes much more easier. Am I clear with this part? So energy has to be supplied. That energy is called as enthalpy of sublimation, and because energy is supplied, it is plus, and the process is called as what? Endothermic. Okay, अभी क्या करना है? Yes, अब तो आप जानते ही हो. पर्पस मालूम है ना आपको? मकसद क्या था सॉलिड को गैस में कन्वर्ट करने के लिए, ताकि आप इलेक्ट्रॉन को आसानी से बाहर निकाल सके. सो नाउ वी आर गोइंग टू टॉक अबाउट व्हाट? रिमूवल ऑफ इलेक्ट्रॉन. सो एनर्जी इज वंस अगेन सप्लाइड. यू नो दैट वेरी वेल. इलेक्ट्रॉन बाहर तो एनर्जी अंदर, एंड दैट एनर्जी इज कॉल्ड एज, oh yes, ionization energy. So we are going to discuss about that ionization energy. So M in the gaseous state will get converted into M positive in the gaseous state. ओके, लॉस ऑफ इलेक्ट्रॉन है दोस्तों, सो ऑब्वियसली पॉजिटिव चार्ज तो आएगा ही. अगर आप अपनी कोई बुरी आदत निकाल दो, आप अच्छे बन जाओगे. सो बुरी आदत मतलब इलेक्ट्रॉन निकाल दो, लॉस ऑफ इलेक्ट्रॉन, अच्छे बनोगे मतलब पॉजिटिव. सो दैट इज M+G. ऑलराइट, और यहाँ पर आएगा फिर डेल्टा IH, एंथैल्पी ऑफ आयनाइजेशन. ऑलराइट, यहाँ पर भी वापस प्लस लिख देता हूँ मैं, +A किलो जूल्स पर मोल. Okay, तो यहाँ तक I guess everybody has understood this. All right. We now go into the halogen. It's in a form of a molecule, diatomic molecule. तो पहले तो मुझे उस molecule में bond होना जरूरी है. Okay, if there is a molecule, it has to be a bond. So I need to break that bond, so that I get it what? Atoms. Covalent bond को तोड़ेंगे तो हमें normally atoms मिलता है, ये आप जानते हो अच्छी तरीके से. So I'm going to bring about the dissociation of this molecule. Alright, but then it is not one molecule, it is half molecule. Alright, so therefore I write it down over here, half delta DH. Energy has to be supplied, so I write it down as +A kilojoules per mole, and as a result of it, this is going to give me X in the gaseous state. Half the molecule has to be dissociated, so I get one gaseous atom, because one molecule of a halogen is comprising of 2 atoms. So therefore, half a molecule of a halogen is comprising of, got it? Yes, it's 1 atom. So Xg. Next, it's a non-metal. Okay, non-metal है तो इलेक्ट्रॉन गेन करेगा, और अगर इलेक्ट्रॉन गेन करेगा तो ऑब्वियसली क्या होगा? एनर्जी बाहर जाएगा. Okay, so energy is released, so it will be what? Negative. और इसे हम लोग क्या बोलते हैं? इलेक्ट्रॉन गेन एंथैल्पी. What do we call it as? Electron gain enthalpy. So what we do is over here is delta EH, electron gain enthalpy. Energy is released, so it's minus of a kilojoules per mole, and that is going to give us X minus. कोई भी बुरी आदत आप अपना लोगे तो आप बुरे बन जाओगे. तो अपनाना है बुरी आदत मतलब इलेक्ट्रॉन को गेन करना है, तो बुरे बन जाओगे मतलब नेगेटिव. तो ये देखो यहाँ पर मिला X minus in the G. Alright, so we have on one side the metallic framework, on the other side we have a non-metallic framework. So this oppositely charged metal ions from infinity comes closer for bond formation, resulting in the formation of an ionic compound. Energy is released. What is that energy called as? Come on, yes. Come on. Oh yes, it's lattice energy. पिछले वीडियो में मैंने बता दिया था. Okay, so lattice energy is the energy released when oppositely charged ions from infinite distance comes closer, resulting in the formation of a bond and resulting in the formation of a ionic compound. So that is what is going to happen over here. M plus in the gaseous state, X minus in the gaseous state are going to come together and result in the formation of the ionic compound, and that's going to be a stable ionic compound, and that's why it's going to be obtained in the solid state, and that is what we call it as UL. What we call it as UL, that is lattice energy. I hope you have understood this. See, this is a diagram now. Okay, so this was DM, and this entire part that we talk about is AM, that is alternate method. Okay, this is a direct method, this is alternate method. लेकिन दोस्तों आप देख सकते हो through the alternate method also, okay, the number of steps are more, but at the end of the day we are going towards the final product. आई बात समझ में? And that is the beauty of enthalpy. That is the beauty of state function. Okay, state function क्या बोलता है? कि we are only interested in the initial state and the final state. We are not interested in the path of the reaction. Whether the reaction goes in one step or whether the reaction goes in multiple steps. Okay, state function ये clearly बोलता है. Because function means what? Dependence. और आगे क्या लिखा है? State. मतलब it is depending only on the initial state and the final state, not at all on the path of the reaction. So as a result of which you can see this. Okay, this is becoming a closed network, और इसलिए देखो यहाँ पे नाम भी हम लोग ने डाल दिया, that is cycle. Alright. So I hope you have understood up to this, everyone. So now, taking into framework about the state function, delta is a symbol of state function, dosto. So what happens is, this is one step reaction, these are multiple step reactions. But in a one step as well as multiple step reaction, the initial state and the final state is same. And therefore the enthalpy has to be same. Okay, enthalpy of one step reaction, that is direct method, and the enthalpy of the alternate method, they have to be what? Same. Okay, this is what it says. So we come to the formula for this Born-Haber cycle, and that formula is, my dear friends, on a one step direct method, what is the value? Yes, it's delta HF. So delta HF is equal to, this is by direct method. Now we go to alternate method. तो alternate method में पहला क्या आएगा? Enthalpy of sublimation. Okay. Next we go for enthalpy of ionization, half enthalpy of dissociation. Okay. Next, plus enthalpy of electron gain enthalpy, and the last one is UL, lattice energy. This is what the formula we get. This is, my dear friends, by direct method. This is by alternate method. Okay? Sublimation, ionization, dissociation, electron gain enthalpy and lattice energy. लेकिन direct method में initial state alkali metal and halogen, final state is MX. In this alternate method also, we start from alkali metal and halogen, and when we end ionic compound. So obviously, चाहे फिर वो direct method हो या alternate method हो, हमारा initial state और final state same है, तो state function यही बोलता है, अगर same है तो यहाँ पे कौन सा sign आएगा? Equal to sign आएगा, and that is the way we can find out the determination of what? Lattice energy. If you know the formula, if you know the values of all the other terms, so you can find out the lattice energy. So this is the most important application, and that is the determination of lattice energy, and on the basis of which we can also comment on the strength of the ionic bond. क्योंकि मैंने आपको पिछले वीडियो में ऑलरेडी बताया है कि ionic bond का strength is directly proportional to lattice energy. So if I want to find out the strength of the ionic bond, I need to find out the value of lattice energy, which I can find it out over here. Okay, so that's the reason I say the most important application is determination of the lattice energy, and thereby we can comment on the strength of the ionic bond. What else we can find out? Yes, and that is any factor which is involved in this particular formula. Okay, any factor which is involved in this formula can be determined, but condition applied. मतलब इधर condition ऐसे स्टार मार्क करते हैं सब लोग. तो condition क्या है? When all the other factors are known. When all the other factors are known. And for example, not necessarily always this particular method is only for determination of lattice energy. Sometimes what we have is we know the lattice energy, but we don't know some another factor. So we can find out this. इस formula में जितने भी factors है, okay, गिन लीजिए आप 1, 2, 3, 4, 5, 6. 6 factors are there. You can determine any one of the factors, provided the remaining 5 factors you know it. Okay, वही यहाँ पर लिखा है. Any factor which is involved in the formula can be determined. Condition apply. All the other factors are known. And for example, if you want to find out the enthalpy of sublimation, तो आपको क्या जानना जरूरी है? Enthalpy of formation, enthalpy of ionization, enthalpy of dissociation, electron gain enthalpy, and lattice energy. ये 5 फैक्टर मालूम है, आप एंथैल्पी और सब्लिमेशन फाइंड आउट कर सकते हो. उसी तरीके से इट कैन बी अप्लाइड टू एनीवन. ऑलराइट, सो दिस इज माय डियर फ्रेंड्स अबाउट द डिटर्मिनेशन ऑफ लैटिस एनर्जी, व्हिच इज सो वेरी इंपॉर्टेंट बिकॉज from the lattice energy, as I am telling you always throughout the entire video, and that is we can find out the strength of the ionic bond. So first we have discussed on the basis of bond length equation. Then we discussed about the Kappa-Stensky equation. So these were the 2 equations on the basis of which lattice energy can be determined. Okay, they are all based on the name of the scientist, and then finally experimental. Okay, because experimental आएगा ना बात तो कहीं है ना एक विश्वास आ जाता है. ये शब्द जो है ना experiment, okay, is an analog of what? Trust. It's a synonym of trust. Okay, because generally experiments never go wrong. Theory can go wrong. Okay, और इसलिए फिर क्या करना पड़ता है? Theoretical approach बदलना पड़ता है ताकि theoretical results are at par of the experimental results. Alright, इसलिए हम लोग ने अभी यहाँ पर experimental technique discuss किया. That was in the form of, once again, the name of the scientist, the 2 scientists, that is Born as well as Haber. Alright, so these are the 3 different ways in which we can determine lattice energy. I hope you all have understood this very well. Thank you so very much.